Dear Flat Earthers, we need to talk. Not because you're stupid, you're not. Some of you have spent more hours studying the horizon, the stars, and the edge of a swimming pool than most working scientists spend on their entire thesis. That's the frustrating part. You did the homework. You just graded it yourselves. So let's go through the greatest hits, every argument, one at a time, with exactly the respect it deserves, which, it turns out, is more than you'd expect. Exhibit A. The horizon looks flat. Correct, it does. From where you're standing, a basketball looks flat too, if you get close enough and squint. Earth is roughly 25,000 miles around. Stand on a beach, and your eye line lets you see maybe 3 miles out before the horizon cuts you off. At that distance, the curve of the Earth amounts to about 8 inches of a drop. Visually, that's nothing. You're not failing to see the curve because it isn't there. You're failing to see it because you're a small, upright mammal standing on a very large sphere using an instrument, your eyeball, that was optimized for spotting fruit, not measuring planetary geometry. Exhibit B, and this one's actually elegant. Ships disappear hull first over the horizon. Sailors noticed this centuries before satellites, before airplanes, before anyone had a reason to lie to you about curvature. A departing ship doesn't shrink evenly into a dot. The hull vanishes first, then the deck, then the mast, like it's sinking beyond a hill. Because it is. That hill is the planet. You grab a pair of binoculars and a friend with a boat, and you can reproduce this experiment yourself this weekend. No agency required. Exhibit C, the Bedford Level Experiment, is from 1838. It's a survey along a perfectly straight 6-mile canal in England using markers set at water level, meant to prove that there was no curvature over that distance. It gets cited constantly online. What doesn't get cited as often is that the original experiment ignored atmospheric refraction, a well-documented effect where light bends slightly as it passes through air of different densities near the ground. And every corrected rerun of the same experiment since has matched a curved Earth, not a flat one. Being the first person to run an experiment doesn't make you right. It just means you got there before anyone checked your math. Exhibit D. Photos of Earth from space are faked. Some of them are composites, technically. Stitched panoramas or renders, because photographing an entire lit hemisphere in one unedited frame from low orbit is a real optical challenge. But composite doesn't mean fabricated. And those composites happen to agree with thousands of independent amateur high-altitude balloon flights. Regular people, on regular budgets, sending up $200 cameras on party balloons for a school project or a weekend hobby. Every single one comes back with a curved horizon. NASA is not sponsoring your neighbor's balloon club. Exhibit E, the ice wall at the edge of Antarctica, allegedly patrolled to stop you from walking off the edge of the disk. Antarctica is real, and it is heavily monitored, but not to conceal an edge, but because 30-some countries operate research stations there under a 1959 treaty that bans military activity and mandates environmental protection. The guards are mostly climatologists in parkas, protecting penguin colonies from cruise ship tourists. It's a strange place. It's not the rim of a dinner plate. Exhibit F. Gravity isn't real. It's just density. Heavier things sink through air like a rock through water. This one's fun because it's almost a real physics idea, just aimed backwards. Density does explain why a helium balloon rises and a bowling ball doesn't, but it can't explain why the moon orbits the Earth, why the tides follow lunar position on a predictable schedule, or why every planet we've observed clusters into a sphere in the first place, including gas giants that have no solid surface to sink toward. Gravity is the reason astronauts float on the space station despite the station itself being made of very heavy metal. Density does not have an opinion about orbits. Mass does. Exhibit G. If the sun is a single spotlight hovering over a flat disk, explain time zones. Explain why it's midnight in Tokyo while I'm eating a sandwich in Buffalo at noon. On a flat model with one localized sun, everyone under that light should get daylight at the same moment. There's no mechanism for half of the map to go dark while the other half doesn't. On a rotating sphere, that's not a mystery. That's just Tuesday. Exhibit H. Polaris. The North Star sits at a different height in the sky depending on your latitude. Sailors used this exact fact for navigation for 1,000 years before GPS existed, measuring the angle to Polaris to calculate how far north they've traveled. That angle changes smoothly and predictably as you move, and it only makes sense if you're standing on a curved surface tilting away from a fixed point in space. A flat disk offers no explanation for why the North Star drops towards the horizon the further south you travel until it disappears entirely below the equator. Exhibit I. Flight paths. Flat Earth maps famously stretch the southern hemisphere into a distorted ring around the outer edge of the disk, which means, under that model, a direct flight between South Africa and Australia should be brutally long, maybe impossible without refueling. In reality, that flight happens on commercial schedules, using close to the fuel a curved Earth route predicts, and nowhere near what the flat map route would require. Airlines are not a conspiracy that enjoys losing money on jet fuel. They would notice a worldview that's off by about 6,000 miles. Exhibit J, GPS. Your phone calculates your location by triangulating signals from a network of satellites in medium Earth orbit, each broadcasting the precise time from an atomic clock that's corrected for relativistic time dilation caused by their velocity and altitude. That correction was calculated using Einstein's equations before the satellites ever launched, and it works. If Earth were flat and those satellites weren't actually orbiting a sphere at the height physics says they are, your phone's map would drift by miles within hours. It doesn't. You used it to get lunch today. So here's the actual thing, flat earthers. None of this was ever about geometry. It's about trust, who you believe, and why, and what it takes to change your mind once you've built an identity around a conclusion. Healthy skepticism of institutions is a genuinely good instinct. It's just currently aimed at the wrong horizon. Question the people who won't show their work. Here, the work's been shown by sailors, by balloon hobbyists, by 19th century surveyors who got corrected, by airlines that hate wasting fuel, and by anyone with a pair of binoculars and a Tuesday afternoon to spare. The planet's not flat, but from way down here, at human scale, on human eyes, I get why, for a second, it might look that way.